And welcome to Naughty Notes. Well, here we go with our special right triangles worksheet. Well, the second part of it, our other special right triangle. Now, I'm asking you to start with this segment right here. That's all I'm giving you. And I want you to measure it. Come on, we're getting good at this measuring stuff. So go ahead and put your Sammy straight edge on there. And, well, I guess you're going to have to use a ruler. My hypothetical example looks like 3 centimeters, well, also known as 30 millimeters. I know sometimes you guys are trained to do that. That's a good idea if the end of your ruler is gummy. Either way, this one is, well, it's clearly going to be 30 millimeters. So let me get that out of the way for now. And let's I'm going to leave that off because do this time we get to swing our compass. That's right. I want you to put the needle on the S, gap it to the T. You never forget your first construction. Yes, this is the infamous perpendicular bisector construction that you all know and love. Love this construction. And you know what to do then. You're going to, well, now you're going to reverse your compass, put the needle on the T, and gap it back to S. And give it a swing. It don't mean a thing if it ain't got that swing. So there you go. Well, we've been doing that since the beginning of the school year. So that's going to give us the 2 points of intersections, as you know. Up there and down, I'm going to name this one. I named it V. You don't really have to name it, but there you go. And we're going to combine two classic constructions. We said it's the perpendicular bisector. Whoops, made that go away. But first we're going to draw this. We're just going to draw this segment here, or these two segments, because this is also the equilateral triangle construction. And we know it's equilateral because I know ST and SV are radii of this orange arc, and VT and TS are radii of the blue arc. And since ST is congruent to itself, holy, transitive property, they're all congruent. So that is a construction for an equilateral triangle. We know that an equilateral triangle is also equiangular. That's kind of important. So let's go ahead. We know you got 60, 60, 60. Oh boy, that first semester stuff is coming right back. And well, that's the construction that we know. And then we're going to do this. Take your straight edge, and this time, remember, you're going to line it up with this intersection, and you are going to draw this, your perpendicular bisector. Now, when you draw that perpendicular bisector, go ahead and put the tick marks in there. I mean, nothing says perpendicular like a right angle, and nothing says bisector like those little congruence tick marks. So there you go. You've got a perpendicular bisector on top of your equilateral triangle. Now, we know something here. This is kind of pretty interesting. I know that these two triangles, and I mean this triangle, and its reflection, well, we can see they are congruent by, well, either side, 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 or side, angle, side, no matter how you want to look at it. Or I guess even angle, side, angle. So you've got a bunch of ways to make those two congruent. They're congruent, and that means by corresponding parts of congruent triangles. We're going to chop that 60 in half like that. And there you go, 30. 30. The number one thing I want you to know is that this triangle that we're going to know and call the 30, 60, 90 triangle is half of an equilateral triangle. And you could also say that this leg, well, the leg here, the long leg, is the altitude of an equilateral triangle. That's kind of cool and handy to have. Let's clean up some of this drawing here. And we're going to do some arithmetic like we did on the last one. Yeah, are you all right with that? Yeah, I'll clean up those construction marks a little bit. You're going to leave them on there. See, I just got the little faint construction marks there. And I got a little picture here of well, I guess you can use this one or you can sketch another one. And I'm going to call A the short leg, and the leg that's next to the 60. And then B this leg, and I'm going to say C is the hypotenuse. Now, I'm just going to suppose that this C has a length of 2. just like this guy right here. And we know that, again, that bisector, that, well, golly, this A must be half of 2. So that's 1. So right now I've got 2 sides here. I've got the hypotenuse and I've got the short leg. And let's plug into the Pythagorean Theorem. A squared plus B squared equals C squared, just like we did for the other special right triangle. We're going to perform the substitution. And then we're going to say, we can keep this going. We're going to square the 2, square the 1. This time, clearly, we're going to subtract. Now, b squared is 3. Clearly, b is the square root of 3. And hence, down here, you're going to say, therefore, b is radical 3. The ratio of the sides of a 30, 60, 90 triangle, 1, 2, radical 3. How's that? Before we go flipping over to the other side, remember, we're doing some measuring there. We measured this, and I suppose we could put this back over there and confirm with our measurement that, golly, this piece looks like it did measure at 1/2, 15 millimeters in our example. But also, I'd like you to measure the third side. So take your wascally ruler like this, and I don't know, what do we get over there? 25, 6. It's looking like about 26 there. 26 millimeters. So we're just going, and we'll come back to that. We'll come back to that after we'll flip over to the other side and just go through a few drills. And remember, the concept is going to be exactly the same as it was for the 45, 45, 90. If I take this triangle, this ratio of the sides, easy as 1, 2, radical 3. That's actually a messy thing to say because it should really be 1 radical 3, 2. Radical 3 is smaller than 2. So any size I make it, if, for example, I increase by a factor of 3, 3, 6, 3 radical 3. Just like that. So let's do a couple examples in simplified radical form. On the back side of your worksheet, again, we're going to be in the ratio of 1 radical 3, 2. It's a little more confusing. Well, it might be a little more confusing than the 45, 45, 90, so you might want to actually write down what the ratios are for a minute. And notice all these angles aren't written. These are understood. I got 30 degrees there. That's got to be 60. I got 60 there, the right angle. That's got to be 30. You could fill them in if you want, but you really don't need, and they're understood. Let's see if we can find the other sides. In this case, we're going to find 2 different sides with 1 given side in our fun triangle. On the green one, the upper left, jot down the ratio. Maybe make it small. This is the 1, this is the 2, this is the radical 3. Now, I don't know how you think of it. I could look at it this way. 1 is to 2 as 7 is to, well, that would be 14. Or I could just say, whatever this is, double it. Whatever this is, multiplied by radical 3. Therefore, 7, 14, I got 7 radical 3 for the long leg. 14 for the hypotenuse. Pretty good, right? Now, over here on the blue, again, the ratios are 1, 2, radical 3. I find it easier. Go from here to here. Well, divide. That's got to be 11, right? And then from here to here, and you know what you got. 11, 11, radical 3. Yeah, you're right. We'll do the 3 easy ones on top first. Then we'll figure it out. Now, the ratio's down here. 1, 2, radical 3. Again, this is pretty straightforward because if this is 6 radical 3, 6 radical 3 is to this side as radical 3 is to 1. Well, that must be the whole number 6. So this side must be 6 and then I double it, and I get this side, which is 12. Okay. Well, can we do some that are a little more challenging? And of course we will. Um, Wait a minute. If I put in the ratios here, 1, 2, this is radical. Wait a minute. So when I go from here to here, I multiply by radical 3. But when I go from here to here, I'm dividing by radical 3. Or I could say 15 is to, well, x, or whatever I call this sign, as radical 3 is to 1. Either way, I'm going to take 15 and I'm going to divide by radical 3. Now, there's a short, easy trick for doing that. And that's going to come up to 5 radical 3. Now, just like we did before with radical 2, it doesn't matter what the radical is. You can take that number 15, divide it by 3. What do you get? You get 5. Multiply it back by radical 3. You're doing two things at once. You are dividing and rationalizing at the same time. So that's 5 radical 3. What's double 5 radical 3? That must be 10 radical 3. Remember, that's about 17 something. That's 1.71. That's your irrational number radical 3 times 10. And oh yeah, don't worry. Well, your teacher, well, and I guess me, will have you turning these numbers into decimals as well. Now down here, 1, 2 radical 3, and this is the one just to show you that it doesn't have to contain a radical 3 or a 2 or anything. If I take this number and I double it, again, that's going to be 6 radical 7. Take this number and multiply by radical 3, 3 radical 21. How easy is that? Well, again, that's the radicals. That's to get through the radical part of your worksheets. Then of course, you're going to have to know how to turn these things into decimals eventually. So let's go back to our, flip the page back over. Let's go back to our beautiful drawing over here. And we had all these measurements. Hey, but didn't we say that it was going to be, let's say this side is, if this is 30, this whole length, then this is 30. Half that side is 15. And then the height must be 15 radical 3. But we measured 26. So there we go again. Let's verify. Because again, I'm never going to go anywhere and say, hey, I want to buy 15 radical 3 feet of this. No, I gotta convert this into something that makes sense. So I'm pulling my calculator. Ooh, I need an upgrade. Ooh, that's more like it. 15 radical 3. That's it. So okay, I'll move it over here. So I'll take the number 15 and I'll multiply it times. There's my 3. That's my radical 3. I verify that looks good. And the equals. Heavens to Murgatroyds, check that out. How close to 26 can we get? Within our ability to measure, pretty good. So there.